Welcome to our latest video on Boombacks. I'm John Johnston, president and owner of Irrigation Accessories Company, better known as IACO. In this short, informative video, we're going to be talking about some of the benefits of installing Boombacks on your pivot or linear. What are Boombacks? Sometimes called offsets, Boombacks are add-on accessories for pivots and linears to relocate or offset the sprinkler 10, 12, or 15 feet away from the center line of the span. As the industry leader, we have Boombacks to fit any pivot or sprinkler. Whether you're retrofitting an older machine or looking to install the newest pivot available, we make a Boomback to fit your needs, such as the IACO Offset, the Alumaboom, or the #1 selling Boomback in the world, the hose boom. We're going to be talking about innovative boom technology in this video. And more important than that creative name our marketing department came up with is what it accomplishes. And that's it eliminates runoff and reduces soil sealing. All right, what is innovative boom technology? It's putting Boombacks on basically the last third of a pivot in opposing directions on every outlet. Here's an aerial view of a pivot with innovative boom technology installed. As you can see at the start of the pivot where the nozzle sizes are smaller, it actually has a higher application intensity. Now out here on the end of the pivot where the application intensity should be greater because of the increased nozzle sizes, you can visually see that it's much less. Now that does several different things for us, and that's what we're going to be talking about. I'm going to let this video run for a second so you can get a good view of it. Now, why is it so important to get it right on the end of the pivot? Because that's where most of your acreage is. As you can see from this aerial graphic, you have 2 acres under the first span, and under the last 30% of the pivot, you have 62 acres. And that's traditionally where it's the hardest to get it right. And that's because that's the fastest moving part of the pivot. You have to have that large nozzle size to try and get the water you need to either germinate or grow your crops. And a lot of times we're putting on too much water and it cannot absorb it fast enough. Now let's look at a drop to Boombacks comparison. Here's a cutaway view of a pivot with a traditional drop spray pattern. Now let's take that same pivot cutaway and add Boombacks on it with the hose boom 15 foot. And now we have a 66% increase in wetted footprint by adding the Boombacks. We haven't changed the amount of water that's being put on, and that's critical. We don't change the amount of water. What we're doing is changing the amount of time it takes to put that water on. And this is how we do that. Take that same pivot, one with Boombacks, one without, and it's moving at the same speed. It takes a longer time to move past a given point just because of that wider wetted footprint. Now let's take a look at this graph. That dotted line being drawn is the infiltration rate of soil. And it can vary by the type of soil that you have. It may be up higher or down lower, but typically it follows the same arc. And that's because the soil can absorb more water when it's dry. But as it gets saturated, we come down, it flattens out because it can absorb less water. Now here, this is a 45-foot diameter sprinkler as it moved by. And this bottom part of the graph is time. So in this amount of time, here's the arc that water drew. Anything above this dotted line is potential runoff. We want to reduce that area. Now let's take that same pivot, but with Boombacks on. And you can see that being drawn, it's flattened it out. Why? Because we've increased the time. Like that animation before that I showed, you can see that it takes a longer time to pass a certain point because we spread that water pattern out. Again, we didn't change the amount of water, we just changed the amount of time it takes. So now this area above that dotted line is smaller, greatly reducing the potential for runoff. Let's look at that same graph, but now with 3 different examples. A smaller diameter sprinkler, a 45-foot diameter sprinkler, and then we take that 45 diameter sprinkler and put on hose booms. Something interesting about this is if you grab this point right here and moved it back, it's going to be this same arc. We haven't changed the amount of water. All we've done is change the amount of time it takes to put it on. So you can see we've greatly reduced this area for potential runoff. We've now more matched that infiltration rate. And as I said before, this infiltration rate may vary for different soils, but it follows pretty much that arc. It may be higher up if you have clay soils, or it may be lower down if you have sandy soils. So here's that wide wetted band again. And what that does for us is it lowers the average application rate, increases the soak time, but it also lowers the application intensity, which results in reduced soil sealing. Now, what we mean by application intensity is how hard the soil is getting hit by the droplets off the sprinkler. Now, you ask any sprinkler manufacturer out there and you pick a point under the pivot, it's being hit by 5 different sprinklers. All that being pounded. So what we do with the Boombacks is we spread it out. You can visually see in the blue, it's the same amount of water, like I keep saying, as in the green, but we've reduced that application intensity. So we're not just hammering that soil. So that's what reduces the chances of soil sealing, that lower application intensity. And that's also referred to sometimes as the instantaneous application rate. Sounds like a complicated term, but it's not. If you just think about turning your pivot on and off really quick, and where does that water touch? That's the instantaneous application rate. And you can visually see by looking at the blue, is which the Boombacks, we've reduced that instantaneous application rate. And the overlap remains the same. Again, we're not changing the amount of water, we're just changing how we apply it. We're using the same outlets, we're just moving the water out. So you can see that wider spread. We've just increased the soak time. Now let's take a typical pivot moving at normal speed. Now we're trying to apply 1.25 inches and took 48 minutes. And everything worked out fine, and you don't visually see any runoff, everything worked out great, then you're fine. But what if you see runoff? What if the water's not getting into the ground? Well, now that runoff means it's not going into the ground. We're distressing your crop. We're not getting that root penetration that we need. So what are we going to do about that? Well, typically people, if they see runoff, the first thing they do is they speed up their pivot. The thing is, you cannot control the average application rate by the speed of the pivot. Average application rate remains static, whether the pivot's moving or it's going as fast as you possibly can run it. That's a controlled static number. Changing the speed of the pivot only changes the depth of the water you're putting on. So by speeding up that pivot, now it went by faster, but we only put on 1 inch of water. We haven't solved the problem. We still have that lack of root penetration. If we had runoff, then we're not getting enough water into the ground for our crops to grow. You speed it up to reduce that runoff, you're still not putting on enough water then. We need to be able to put on the proper amount of water at a rate that the ground can absorb it. So if you have tight soils or hilly soils, any application where you have runoff, we can help with Boombacks. So now let's look at that. Let's move it at normal speed. And again, we increase that time because of the wider wetted footprint. but we're still putting on that same amount of water. Like I keep saying, we haven't changed the amount of water putting on. We just increased the time by spreading that water pattern out. So now we get that increased root penetration. We've eliminated that runoff. We've eliminated the chances for soil sealing. Your crop's got the proper water that it needs. It's gone into the ground. So we've lowered that average application rate. Now let's take a look at that formula for average application rate. That's the rate at which the depth of water increases if applied uniformly throughout the wetted area. Sounds complicated. Pretty straightforward though. We take the flow rate, the system flow, the gallons per minute per acre, the distance from the pivot. At any point we can pull that out from the center, from the beginning of the pivot to a distance. We want to figure out for that specific point. And the COV, that's just the coverage, the sprinkler throw diameter in feet, the coverage of that sprinkler. Let's look at a really specific example here. We're going to look at a Rotator 3000 orange plate 20 psi. So the flow rate is 6 gallons per minute. The distance we picked is 1,300 feet. The coverage 72. Now this 72 down here, that's a static. That's part of the formula. So we put in that coverage, 72 here, put in the 6 gallons per minute and the 13. That gives us our 1.5 inches per hour, and that's if we're using just traditional drops. Okay, let's take that same example, and all we're going to do is add Boombacks. Still got the 6 gallons per minute per acre, the 1,300 feet, but now we've got that wide wetted footprint. We put hose booms on, 15 footers, in opposing directions. That gives us an extra 30 feet of spread. So what's that do to this 72? It jumps it up to 102. So that's a 33% decrease. Just by doing the math, now we're putting on 1 inch per hour. And that's what we call innovative boom technology. We've lowered that average application rate. We've increased that soak time. We've reduced the chances for soil sealing. We had a study done called The Efficacy of Boom Systems in Controlling Runoff Under Center Pivots and Linear Move Irrigation Systems. It's quite a mouthful. It was done by Dr. Troy Peters at WSU in Prosser, Washington, and it was a straightforward study. We didn't look at yields. We didn't look at reducing water usage. All we wanted to look at was what's the difference in runoff if you are using drops and you're using Boombacks. That's the only thing we looked at with this study. Pretty straightforward. Now down here you see different irrigation events. The first event wasn't that significant a difference. The drops only had a 3% more runoff than the boom systems. That's because if you remember that chart where I had the infiltration rate, if the ground's dry, it can absorb more water. But just by the fifth event, that jumped up to 24%. The drops had 24% more runoff than the booms did. Now you can look that up online. It's an ASA BE Technical Library, Volume 30. It's also on our website, boombacks.com. Just click on the Technologies button, and that'll take you to Innovative Boom Technology, where you can download your own copy of that study. Now that's what we call Innovative Boom Technology, a 24% reduction in runoff by the fifth pass, proved by Dr. Troy Peters. We originally did this with a grower down in California. They were having trouble trying to germinate carrots, especially on the end of the pivot where the nozzle size was so large. The infiltration rate of the soils, they were so tight in California. You know, if it rains in California, it floods. To get the water into the ground, we were struggling with that. So what we did, we came up with Innovative Boom Technology, putting Boombacks on every outlet on the last third of the machine. And it was very successful. We were able to germinate carrot machines. Originally, we thought, okay, we have a system to germinate carrot seeds in California, very specific. 3 years after the fact, I went down and interviewed them, and this is what they were telling me: a 33% water savings, 37% increase in yields, increased crop quality, increased crop uniformity, and runoff was practically eliminated. At that point, I realized we had more than just a carrot germinating system. We had something far greater than that. And if you look at these numbers, like the 33% water savings, where does that come from? That's because we have eliminated that runoff. That runoff now is going down into the ground. It's being absorbed. We're getting that root penetration, and that's why you have increased yields, increased crop quality, increased uniformity. That runoff is tremendous. You're wasting a lot of water. But the other thing is you're not getting enough water into the roots of the crops. So now with this system, we're pushing the water into the ground. We're giving the crops the water that they need, and we're reaping all the benefits from it. This is our hose boom. I wanted to talk a little bit about that and some of the things we've engineered into it. We've been manufacturing Boombacks for 30 years, and the hose boom is the culmination of those 30 years. We have a re-engineered bracket for clamping, tighter clamping, so it doesn't slip on the main pipe. It's precision stamped, robot welded. We have slotted U-bolts for easier assembly. It's galvanized. It's not a painted product. It's hot dip galvanized. Really easy assembly. Superior clamping, have custom diameter U-bolts, which allows it to just drop over the tubing. We had to go to a odd size tubing to accommodate the hose because this is a fully hose lined product. So we designed our own U-bolts to make it easier to assemble. Something off the shelf was just too tight and it wasn't very easy to get installed. Have a heavy duty 1-inch bracing. It used to be a 3/4 inch, but it just wasn't strong enough for what we wanted. The larger diameter tubing was to accommodate the hose, but the other benefit of that, it made it far more rigid. It's the most rigid boomback on the market. Comes with a factory bend. That's something we do in-house before you ever get it. Also comes with a torque clip and a side force control fitting. We haven't talked about those, but that makes this product work with part circle sprinklers. You can't hang a part circle sprinkler on a piece of hose. It has something that's called side force that blows it back, and they also have rotational torsion. The torque clip and the side force control fitting solve those two problems. So this product can work with any sprinkler on the market, whether it's a vibrating sprinkler that needs a length of hose or it's a part circle sprinkler. Has a chafe-free flare. Like I said, it's fully hose lined, factory installed. When you get it, the hose is already installed, which gives it built-in dampening. As we like to say, it's not just a piece of tubing. There's a lot of engineering that went into this. Like I said, we've been manufacturing Boombacks for 30 years, and this is the culmination of those 30 years of what we've learned. And with the hose boom, it can work with any sprinkler on the market. It even works with the new Nelson white plate up top sprinkler. You just invert the installation and you can now have innovative boom technology on your corn with an up top sprinkler. So with that one product, you get the hose boom 15-foot traditional with a length of hose. It also works with part circles, as I mentioned, and it works with the up top sprinkler. Those 3 sprinklers with this one part number. And it's made for every clamp diameter that's being manufactured today. And like I said, any sprinkler on the market, this Boomback will handle it. Whether it's a part circle or a vibrating sprinkler that needs a length of hose. And you can also put 2 of them on one outlet, and we call that the double hose boom. We had a project down in Zambia where they had a really tough time getting the water into the ground. So we really wanted to lower that average application rate even more. So we split the outlet and put 2 Boombacks on. The other thing is if you have an older machine or if it's a machine being manufactured internationally, you might not have the outlet spacing that you need. With this double hose boom, you can have that outlet spacing. If you have 10-foot spacing, but you really need a 5-foot spacing, you can do that. We just split that outlet and run 2 boombacks off of one outlet. And again, this comes for every clamp diameter being manufactured today, and it works with every sprinkler on the market. This is our website, boombacks.com. We have lots of videos out there, not just this video. We also have a YouTube channel. Go to YouTube and search on Boombacks and you'll find our YouTube channel. We have installation videos. We have more informative videos. I mentioned a little bit about the part circle application. We have a dry wheel track solution video, and we're working on a new one that should be up soon. Or you can feel free to contact us directly. You can see our phone number and my email down here in the bottom right hand. Again, that's boombacks.com. So whether you're a grower talking to your dealer or you're a dealer talking to your OEM, make sure you ask for our Boombacks by name. Ask for the hose boom by IACO.